Hello and welcome to Lab 3. We're talking about n-grams. An n-gram, in the context of parsing natural languages such as English, is a sequence of n consecutive tokens, which we might define as characters separated by whitespace, words, from some passage of text. Based on the following passage, I really, really like cake, we have the following 2 grams. The concept of a gram is really simple. If we have a sentence and we want to separate it into grams, we are simply selecting consecutive sets of words of length n. And in this case, here, this example, that length is 2. So for I really, really like cake, we take the first 2, the second 2, third 2, and the fourth 2. And that's as many as there are. These are the 4 2 grams for this sequence of tokens, and token is another word for word. So we can expand this concept to any n. So if we wanted to do this for 3 grams, it's the first 3 words, the second 3 words, and the third 3 words. And that's all we're doing. So this is our list of 2 grams, and this is our list of 3 grams. And each gram, which is a set of n words, again, is stored as a tuple. If you're not familiar with a tuple, it's identical in storage to a list, except it's immutable, right? So if we have a list in Python of 1, 2, 3, and a tuple in Python, denoted by parentheses, the main difference is that when we want to do something to a list in Python, like add to it, we can. That's simple. We can mutate the list. We can change the contents of the list. But a tuple, we can't do that for. If we attempt to append to it, we'll get an error because the tuple class, this is a class in Python, has no append function. It doesn't support any of the functions that the list supports that would mutate the contents of that list. Okay, back to the lab. Among other things, n-grams are useful for describing the vocabulary of and statistical correlation between tokens in a sample body of text. Whoops. We can use an n-gram model to determine the likelihood of finding a particular sequence of words after another. This information, in turn, can be used to generate passages of text that statistically mimic the sample. So this is actually pretty cool. What you'll be able to do once you're finished writing your functions for this lab is feed the functions that you've written any body of text, separated into tokens, and you'll have a function that can generate a set of text that mimics the sentence structure of the set of text that you gave it. It doesn't work well for common language, but if you have things like abstract poetry, you can get some samples that actually mimic it pretty well. But you'll be able to do that later. We can convert the above 3-gram list, that's this, and these things here that we have, into the following lookup structure, where the first token of each n-gram maps to all sequences that follow it in the text, and we get this structure. So what we're saying here is that we can sort the grams of some n length that we get from a list by what their first token is. So I really, really like cake. We got the following 3 grams. I really, 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 really like and really like cake. This gram, I really, really, starts with the token I. So we will put it in a category. Are there any other grams that start with an I? No. So we move on. Next category. Are there any other grams that start with really? Yes, we have this one and this one. So these 2 are in the same category. So now that we've sorted the grams from the sentence by their first token, we can create this lookup structure. And we'll do it by creating a dictionary. A dictionary, as you know, has key-value pairs. We have some empty dictionary. The key is the first thing. This part is the key, and the value is whatever comes after the assignment, or is whatever comes after the equal sign. We'll say the string value. These are both strings. And so now we have a dictionary with one key-value pair, the key being the string key, and the value being the string value. And what we want to end up with is a dictionary that stores a bunch of key value pairs where the key is the primary token and the value is a list of all the subsequent strings or subsequent tokens that came after that key, that came after that token. So what we'll end up with is this dictionary here. We can see it more clearly if I print it out in dictionary.items. Items returns tuples that contain the key in the first slot and the value in the second. So you can see that the structure of our dictionary is the key I corresponds to a list with one element in it, a tuple that has two elements in it. Really, right? Because that's the only sequence of tokens that comes after I in the text. I, really. Okay. And after really, we have another list that has two values in it. Two tuples, 1, 2, each of which have two other values in them. And those are the different two token sequences that follow the token really in the text. There's really like, and really like cake. Okay, and so now we have this dictionary here that stores those values for us. What is next? Okay, so generating this is the first function that you have to complete, and that function is compute n-grams. Now you only have to complete one other function once you've done this correctly, and that is all the way down here, gen passage. Gen passage will accept the dictionary you just created. Over here, I called it DCT, and the amount of words that you want the newly created passage to be, and it will generate that. So that's what you'll have to do. So given the dictionary you created, which is a way of storing roughly the sentence structure, the nature of the sentence structure of some passage or body of text, and the length that you want this to be, which is the more simple parameter, and return a passage, a new body of text of this length that is based on the structure you just analyzed in this dictionary. And it will work in the following way. This is step by step how you should go about this problem. Really and truly. This is how to do it. If you don't understand what you're doing or what you should be working on, you're not sure how to start gen passage, this tells you how. This is instructions for doing it. Number 1, select a random key and use it as the start token of the passage. It will also serve as the current token for the next step. Well, that's rather simple. So in order to choose a random thing from an iterable in Python, we'll just use the random method, right? So we'll start by importing random, which I believe might be done for you. Yeah, that's done for you here as long as you run this. And then we'll be using the choice function. If you have some list, 1, 2, 3, 4, and you use the choice method on that list. Oh, whoops, I'm sorry. Random.choice from list. It will choose a random item from that. You can do this over and over again ad infinitum and get random selections from your iterable. So now back to part 1 of our instructions. Select a random key from the dictionary and use it as the start token of the passage. It will also serve as the current token for the next step. Okay, so just a second ago, we saw how we can get a random item from a list, but this works for, I think, any iterable or most iterables in Python. And so in the same way that we did earlier, where we said random.choice on list got us a random value from that list, given DCT, we can also select random things from the different iterables in this dictionary, and there are 3. The first is the keys, which is what we'll do in a moment. If I call dct.keys, I'll get back this special iterable with a list I and really. That's I here and really here. The keys, the things in front of : I can call dct.values, and get a similar interval, a dict values iterable that has just this list and does not have I or really, so only the things after the colon. And finally, as you saw me do earlier, I can say dct.items, which gives me back a set of key value pairs as tuples, each tuple first containing the key and then the value. You'll notice that these are not pure Python lists. These are special lists, special iterables from the dictionary class, from the dict class in Python. So in order to use them, we first have to convert them to a list in order to use them with random choice. So we'll say dct.keys looks like this. We can convert that to a list by simply wrapping the list function around it. And now we have a pure Python list. And we can now get a random key from that list by saying, just as we did before, random choice on list on dct.keys. What am I doing? Oh, I missed keys is a function. Keys is a function. There we go. We got really. We can do this over and over again, and we'll get I or really randomly. Cool. Step 2, select a random tuple from the list associated with the current token and append the sequence to the passage. Now I'm not going to go through step 2 and 3 as explicitly as I did with step 1, because then what are you even doing? But it is important to note and to be very clear about the fact that the last token of the selected sequence will be the new current token. So we have some passage that's an empty string. We chose I in random.choice, right? We did this, and we didn't get really 5 times. We got I. Let's say we got I. And then we append that to our passage because that's the first thing. Because I only has one value in our dictionary, it's the tuple, really, we can select that. We would do a random choice, but there's only one, so this is what we would randomly choose from our single item thing. We would append that to the passage, so now passage is going to be I, really. That's our passage. I'm doing it explicitly. You'll have to figure out how to generalize it. And now, because really is the last token that we used, really is the last token, it was here, this is the new token that we're generating based off of. So now, we look to our dictionary, we ask, is there an entry in our dictionary for our last token? There is, and here are 2 possibilities for sequences that can come after it. We'll randomly choose one of these. Right? We got really like. Cool. So now passage appends really like. And that's our new passage. And now like is our new word. All right. Is there a like in our dictionary? There is not. There is no like in our dictionary. And we knew that, but for a longer passage, you wouldn't know that. So what do? If the current token is a key in the dictionary, then simply repeat step 2. Keep going, keep going through, finding the last word that you chose from your random gram, and using it as the new key in the dictionary for a new sequence. But if it's not, select another random key from the map as the current token and append it to the passage before repeating step 2. So we had a key error here because our last token in our passage, the last thing that we got was not a key in our dictionary. We don't have a set of values that come after the word like, so we just select another random one. Given all the things we've done here, I'm sure you understand how to do that. Important thing to keep in mind. You will use random.choice whenever a random selection needs to be made, always. In order for your results to be reproducible, be sure to sort the dictionary's keys, which recall are in no discernible order, before selecting a random one, like this. Assuming n-gram dictionary is the dictionary, random choice, sorted function on n-gram dict.keys. Okay, So what's saying here is that in order for us to test if your function actually works, your random functions need to behave in the identical way that our random functions, or that the whatever the grading server's random functions behave. Those behaviors need to be identical. You have to set it up correctly in order for the results to work the same on different machines. And so we do this in two different ways. Firstly, to correct for hashing differences, we're sorting our dictionaries. So on top of calling keys, you'll always call the sorted function. And then the only random function that you'll be using is the random.choice function. You'll see in the tests that we use this random.seed. This sets how randomness works, right? So if I have some lists, once again, 1, 2, 3, 4, and I call random.seed 10, whatever. And then I do random.choice list. So let's see, I got 1, 4, 4. All right, so now if I set that seed again, and then I attempt to do more random choices, once again, I will get 1, 4, 4. And this will happen over and over again, because by setting that seed back to what it was when we started doing random selections, we're resetting whatever insane algorithm that I don't understand that creates random choices to start from the same place. I don't know how those algorithms work, but the seed is the starting point, and it's what the random choices are based off of. And so you can see again, 1, 4, 4. So that is lab 3. You have 2 functions to do: compute n-grams, which returns the dictionary based on the sequence of tokens, and generate passage, which will accept that dictionary you just created and the amount of tokens to generate, and we'll use this methodology and this way of randomness, this way of randomness to generate a passage of this length. So good luck. As a reminder, on our class website, there is so much information on syntax for various data structures, and also all of these beautiful TA's office hours, which you should go to. So thank you for listening. Good luck with lab 3, and see you around.